setup cái RESTfull API trước trong các cái form của nó. Ok, form XML. Rồi sau đó mình define cái method, test method, build cái response. Generation object, examination Json version. Config của nó thì mình có thể config bằng dòng lệnh. Có thể tham khảo thêm.
We'll cover the web.xml file as well as work on our source code for the web services in the next video. Having worked on the pom.xml in the previous video, where we added in the dependencies to the Jersey framework, it's now time for us to work on the web.xml file of the project. This is the deployment descriptor file for our web application, and it includes configurations for the deployment of an app into a servlet container. And I'll just paste in the contents of the web.xml for our own RESTful app. This will have the name of Java REST API, and then we define the servlet which needs to be loaded. The name of the servlet is my jax-rs servlet. Note that jax-rs is the specification which Jersey implements in order to build out REST APIs, and the class for the servlet is org.glassfish.jersey.servlet.servletContainer. So this is a built-in servlet container class available in the Jersey framework. And then to point the servlet container to the class files which make up our application, we set a parameter in the form of an initialization or init param. The name of this parameter is jersey.config.server.provider.packages, and this needs to point to a Java package containing the classes corresponding to our RESTful application. So the package which we will create just a little later is com.jaxrs Wbservice. Following that, we set the servlet container to load when the application starts up. So that takes care of some portion of the servlet container definition, but we're not quite done. We also need to map this servlet to a specific set of URLs. This is where we have the servlet mapping. So we map the myjaxrs servlet, which we have just defined, to all possible URL patterns within our app. So we set the URL pattern value here to /star. When we begin coding up our web application, we will map various methods to different URLs, and all of them will be hosted by this servlet container. And that servlet container in turn will run inside Apache Tomcat. Just so you have a full view of the web.xml, I'll just minimize the project pane, and you can now take a look at the full schema location at the top. However, it's now time for us to move on and write some code for our web services, which can communicate using the REST API. I'll minimize the project pane again, and now inside the main directory, and we will now need to create a new Java package, but first we will need to create a new directory for all the Java sources, and the name of this folder is Java. Once we do that, we can right click and then create a new package. The name of this package, well, I'm going to set this to com.jaxrs web service, and while you don't need to give it this exact same name, you must ensure that it matches the param value which we supply to the init param corresponding to the package which the Jersey framework will look for. So we now have the package which will include the REST API implementations. And as for the implementations themselves, let's start off with something simple. Inside this package, we will now create a new Java class. And since it is a basic application which we will first implement, let's call this one Hello World Service. And once we have the class stub in place, I'll go ahead and hide the project pane. and then paste in the code. Before diving into the details, let me explain at a somewhat high level what exactly we plan to do here. When a client application submits a GET request to the URL/greeting in our app, we want to return to them a greeting in the form of a string. A GET request, just in case you're unfamiliar with it, is the way for a client application to request a resource from a server when making use of the REST API. This involves a different way of thinking as compared to the SOAP protocol. A GET request when using the REST API usually means that you only wish the server to read data and send it over to you, and no write operations or updates are required at the server end. With that said, let's get down to the implementation. We start off by importing jakarta.ws.rs.get, and this is an annotation which is used with a method which can respond to a GET request. Next, we also import jakarta.ws.rs.path. This is also an annotation which we can attach to a class, and this effectively binds a URL or URI pattern to the Java methods defined within the class. For now, we also import jakarta.ws.rs.core.response. However, we will make use of that a little later. A quick thing to note, if you do plan to deploy to an older version of Tomcat, that is version 9 or older, you will have referenced an older version of Jersey in your dependencies, say 2.33 and older, in which case your imports should reference Java X instead of Jakarta. Alright then, now that we have two different annotations which are imported here, how exactly can we put them to use? Well, first of all, we have a class definition here called Hello World Service, and this has been annotated with path. When we do that, we can specify the URL pattern which needs to map to this class, and we set this to /greeting. What this means is that when a client sends over a request to the path /greeting corresponding to our web app, one of the methods in the annotated class will be invoked. Let's move along to the methods then. To start off, we only have a single method. This is called myGreeting, and its return type is string. So it will return a greeting in the form of a string, and you can see that we simply submit the message, "Welcome to the world of REST APIs in Java." So this is the method which will be invoked when a client submits a request over to the URL/greeting. However, it is not just any type of request for which myGreeting will be called. It's only a GET request which will invoke this method. As I had mentioned earlier, there are different types of HTTP requests depending on the kind of request being made. A GET request is a request to get data from the server, and the data which will be returned to the client is the string which you see in front of you. Alright then, let's make sure that our application works, and for that, it's now time for us to build, package, and deploy our app. To do that, we will make use of the Maven tool, and we can run it from the command line. In my case, I'm going to bring up my shell from the terminal session which is available in IntelliJ itself. So pulling this up takes me over to the root of my project directory, which is precisely where my pom.xml is located. And then to build and package our application, we can run the command maven clean package. This is in fact two commands which we execute here, maven clean and maven package. The clean command will clear out any previously generated build artifacts, and if this is the first time you're running this command, there will be no such artifacts to speak of. The maven package command will build the application and then package it into a WAR file. That is the format which we had set in the packaging field in the pom.xml. So let's just proceed with this command, and soon enough, you should see a build success message. And if you'd like to see all of the artifacts which are generated, well, I'm going to minimize this console output here and then head over in IntelliJ to the project pane. If the view has been reloaded, you'll observe that there is a newly created directory called target, which now appears within the project. And upon expanding it, there are a number of different generated directories. And significantly, there is a rest-app.war file. This is the file which includes the compiled classes of our application, also the dependencies, and any other resources needed for our web services app to run. To check out its contents, we can make use of the tar utility, and for that, let's pull up the terminal once again, and then run the command tar tvf against the rest-app.war file. This of course is inside the target folder. This will render the contents of the war file in the form of a table, and this is the output which is generated. At the very top, there is the manifest file, and this includes useful information including metadata about the archive itself. And scrolling further along, we get a glimpse into the jar file contents. Importantly, you'll observe that there is a Jersey client.jar file, and though this is not a direct dependency as specified in our POM, it is required by one of the Jersey dependencies which we have specified. Scrolling further along, we'll observe that the compiled version of our Hello World service source file, so hello world service.class, is packaged within this war file. There are some Jersey HK2 jar files as well. And we can see a whole host of dependencies packaged here, including the Jersey container servlet. So we now know that this war file includes our compiled class as well as the dependent jar files, which means that it is possible for us to make use of it. For that to happen, however, this needs to be deployed to our Tomcat web server. We will do precisely that and also test out our app in the next video. In the previous video, we coded up our application to implement a simple REST API call. So, it is capable of responding to a GET request submitted to the URL/greeting with a simple message, "Welcome to the world of REST APIs in Java." We also packaged the app into a WAR file using Maven, and now it's time for us to deploy it. For that to happen, all we need to do is to copy over this WAR file in the target directory over to our Apache Tomcat web apps directory. And the moment we do that, first of all, let's confirm that the deployment has taken place. I have pulled up my file explorer and will navigate over to the directory where Apache Tomcat has been saved. So this is the Apache Tomcat folder, and within that, we head over to web apps. And you'll observe that the rest-app.war file is located here, and significantly, its contents have been unpacked into a rest-apps directory. Furthermore, if we head over to the shell session where we started up Apache Tomcat, right at the bottom in the logs, we can see that the deployment of a rest-app.war has been picked up by Apache Tomcat and that the deployment is complete. What remains then is for us to test out our deployed app. And for that, let's pull up a browser and then navigate over to the URL for which we have a web service in our app. So this is localhost port 8080/rest-app. This is of course the name of the deployed war file, and then /greeting. /greeting of course is the URL which maps to the Hello World service class. That class, you will recollect, includes a myGreeting method which is capable of responding to a GET request submitted to the /greeting URL. And in fact, when we navigate in a web browser to this URL, it is a GET request which will be submitted. So let's see whether the greeting appears in the browser when we head over to this URL. And sure enough, it does. So we have now successfully built an application which is capable of responding to a GET request. So this is the power of REST APIs. It is possible for us to invoke functions which lie on a remote server using any client application, including a web browser. Now, I did mention that when we navigate to a URL from a web browser, it is a GET request which is submitted. However, there are other utilities which are available and are very easy to use, which can also be used to submit HTTP requests. And in fact, they make it easy to send different types of HTTP requests. Specifically, let's now make use of curl. This is a popular command line utility which should be available by default on most flavors of Linux and also macOS. And if you just bring up a new shell session, all you need to do is to run the command curl followed by a URL. This will submit a GET request to the corresponding URL. So when we submit this to REST app/greeting, what is returned to us is the message from our API. Now the communication between the client application, which in this case is curl, and our server app, which is hosted by Tomcat, happens via HTTP. This means that we have submitted a GET request using HTTP, and then our application has sent over a response also using HTTP. This means that the response not only includes this string message which we see here, but there are also HTTP headers. And to view the headers in the response and not be concerned with the response body, well, this is a command which we can use in curl. So we run curl with the -i flag and then specify the URL to which the request is to be submitted. And these are the headers in the response. We will dive into the specifics of the response a little later. And in fact, we will see how it is possible for us to construct a response object. However, let's take a quick look at the default contents of the header. You'll observe that the content type has been set to text/HTML, and we will see later on how it is possible to construct a JSON response in order to communicate objects. Also, the first line in this output, pointing to an HTTP 404 status message, in fact, means that the requested resource was not found. This is something which we can address soon and return an HTTP 200 message to indicate that everything was okay with the request. Let's move on back over to the IDE and make a few code changes. The way things are in our Hello World service at the moment, we have a single URL, namely /greeting, which is mapped to the Hello World service class. This means that this class can only include one method which is capable of responding to a GET request. However, what if we wanted multiple such methods? Well, for that, we will need to make a few changes. First of all, let's configure the path mapping to this class so that it is the URL/ws which maps over to Hello World service. And then we can define a separate path for individual methods. So in addition to the GET annotation, we can also attach the path annotation to the myGreeting method and then set the path to /greeting. The full URL corresponding to this method will then be /ws/greeting. This definition will allow us to define multiple methods in the same class, each of which maps to a different URL path. So let's redefine the myGreeting method now, specifically by returning a response object rather than a plain old string. And for that, we can make use of the response which we have imported, which is jakarta.ws.rs.core.response. And for that, well, this is the new definition of myGreeting. So we still construct the same message string. However, we don't send it as is, but in fact as the body of a response. The way to do that is to create a new response object. And first of all, we set its status to 200 so that the status does not show up as 404 as it previously did. And importantly, a status code of 200 also conveys that everything is okay. And then for the response, we define the entity to be returned. We will later see that it is possible for us to pass along objects in here. However, in this case, we simply pass along the message string. And then we invoke the build method in order to build a response out of the different attributes which we have just specified for the response, specifically the status code and the message. Furthermore, you'll observe that the return type of the myGreeting method is now a response rather than a string. And now to test out these changes, let's pull up the terminal and then rebuild and package the app. So we run maven clean package. The build success message should pop up in just a moment. And then let's copy over the newly created WAR file over to the Tomcat web apps folder. Heading over to the shell where Tomcat was started, we can confirm that the deploy has gone through. And then to submit a GET request to the endpoint, let's pull up the browser once again and head over to this new URL, rest-app/ws/greeting. The URL /ws of course points to our Hello World service class, and within that /greeting over to the myGreeting method. The return type of myGreeting is now set to be a response rather than a string. However, what we observe in the web page is in fact identical to the previous version of myGreeting. This is because the web browser merely renders the body of the response which is returned. And to test out the differences, let's head back over to the shell and make use of curl once again. So we submit the curl request, specifically a GET request to the same URL, rest-app/ws/greeting. And it is the same body which is returned, which of course contains the same message. But now, let's take a look at the headers by submitting the same curl request but with the -i flag. And this time, the headers are in fact different. First of all, the status code at the top now says 200 exactly as defined within our response object. So 200 of course represents that everything is okay. And the content type, which was previously text/html, now is simply text/plain. So now that we know how to construct a response object, in the next video, we will move on to get requests with parameters. In the previous video, we introduced a few changes to our Hello World service source file. So we have now introduced a path for both the class as well as the myGreeting method inside it. This means that we can define another method inside the same Hello World service class, which is also capable of responding to a GET request as long as it is to a different URL path. That is what we will now explore, and also how a GET request can process a parameter. To demonstrate that, let's first replace this myGreeting implementation with the old one. So this one returns a simple string, "Welcome to the world of REST APIs in Java." And then following that, let's add in a second method definition. This is also called myGreeting. However, we have overloaded that function since this version of the method takes in a parameter. Moreover, that parameter is passed on in the form of the URL path. So, what exactly does this translate to? Well, first of all, we attach the get annotation to this method. So this is also capable of responding to a GET request. And for the path, we set this to /greeting/param. So the parameter to this method will be passed along in the URL after greeting/. So we define this parameter inside curly braces and give it a name of param. And then, well, let's get down to the method signature. So the return type first of all is a response. And then let's move along to the parameter And we set this by making use of the path param annotation. This is the annotation which we use in order to extract parameters from the URL corresponding to the method, and we set the value of the path param to param, which is the same as the parameter which we specify in the URL. So whatever we pass along after greeting slash will be assigned to the argument of name to the myGreeting method. This parameter will be cast as a string. If things seem a little abstract right now, it'll all become much clearer when we test out this function later on. But for now, let's just go along. So we have a parameter which has been extracted from the URL. And what exactly do we do with it? Well, we construct a new message string. So we say welcome followed by the parameter, and then this is the world of web services. And then using the message string, we construct a new response object. So we set the status code to 200 and set the entity to the message string, and then build out the response and then return it. So we have two different methods implemented here. One maps to the URL /ws/greeting, and the second one maps to /ws/greeting/ and then a parameter. The question now is, will these code changes work? Of course, the surefire way to find out is to pull up the terminal and then rebuild and package the app. Once the Maven clean package command has run, well, a new war file will be generated, which we copy over to the web apps directory. And once the changes have been picked up by Tomcat, let's head over once again from the browser to restapp/ws/greeting. So this will submit a GET request to this URL, and this should invoke the first of the myGreeting methods, which does not include a parameter. So we see the standard text message returned to us in the body. However, what now if we navigate over to this URL? This is restapp/ws/greeting/Lunicon. So with this, Lunicon should be picked up as the parameter by the overloaded myGreeting method, and we should have a new string returned to us which includes the Lunicon name. So let's submit this GET request, and we do see welcome Lunicon in the return response. So two different GET requests now return two different responses. One of them is capable of accepting a parameter and then constructing a new string out of it. And now let's move on to a few different ways in which to define a response to an HTTP request. Heading back over to our source, hello world service.java, and we will now define exactly what the type of each response is. For that, we will need to add in a couple of new imports. First of all, we import the produces annotation, which allows us to define the type of content produced by our HTTP method. The content is defined in terms of a media type, and it is the media type which we import next. So how exactly can we use these? Well, let's first head over to the myGreeting method, which does not take in a parameter. So we attach the produces annotation to this myGreeting method, and within parentheses, we set the media type of the return response to plain text. This corresponds to the enum value of media type.text_plain. So this correctly describes the response type of this myGreeting message, and in fact, this is the same response for the next myGreeting as well. However, there is a different way to set the content type of the response without using the produces annotation, and that is what we will do here when we construct the response object. So we replace it with this invocation. So when defining the response, we set the status code to 200, then we set the entity to the string message, and then we set the type to media type.text_plain. So this has the same effect of the produces annotation, and we will test that out in just a little bit. So once this response has been built, Well, let's save things down and then let's repackage our app. So we'll run maven clean package from the command line. Following that, we'll deploy the war file over to the Tomcat web apps. And then once the deployment is complete, well, it is the headers of the return response which we'll need to check out. So rather than the browser, let's make use of the curl utility. So from the command line, let's run the curl command. So we submit a GET request to the URL endpoint restapp/ws/greeting. And sure enough, this returns the string message. However, let's take a look at the headers. Sure enough, in the headers, we can see that the response status code is 200. And importantly, the content type is plain text or text/plain. Moving along then to our second myGreeting method, which of course can be accessed from this URL. And in my case, this includes the parameter of Lunicorn. Sure enough, the body includes the parameter. And now let's take a look at the response headers. And once again, the status code is 200. And importantly, the content type is again text/plain. So we have now seen two different ways in which we can define the content type of the return response. However, we know that the response type can be more than just plain text. And let's now construct an HTML response. So I'll modify the myGreeting method, which does not take in a parameter, with this. This time, we just include some basic HTML in the response body. So we make sure that REST APIs in Java is included in bold text. So we place it inside HTML bold tags. Significantly, you'll see in the produces annotation that we set the returned content type to media type .text_HTML, which maps to text/HTML. Similarly, let's modify the myGreeting method, which takes in a parameter with this definition. So in this case, we again include HTML tags inside the message string. So the name will now be in bold text. And then we also set the media type to text_HTML when setting the type of the response. So let's see what effect this has on the return response. So let's save things down. And then from the terminal, we can once again run Maven clean package. Once that is ready, it's time for us to deploy to Tomcat. And of course, once that is complete, we can use curl to submit a GET request to this URL. So this is the myGreeting method without the parameter which will be invoked. And we can see that the bold tags are in fact included in the response. Let's check the headers though, where we can confirm that the content type is text/HTML. And let's quickly confirm that myGreeting with the parameter returns a message with that parameter in bold text. However, to render HTML correctly, we will need to make use of a web browser. So let's pull one up and then head over to restapp/ws/greeting. And without the parameter, we can clearly see that the text REST APIs in Java now appears in bold. So the return type is in fact in HTML. However, let's confirm that for the other myGreeting method as well. So when the parameter of Lunicorn is supplied, we can confirm that the returned HTML does include that parameter in bold. We have now covered the implementation of simple REST APIs using the Jersey framework. This has allowed us to define responses to incoming GET requests submitted to specific URLs. And so far, we have covered responses in the form of both HTML and also plain text. However, what will be very common when you build out your own web services is transmission of objects. And when it comes to REST APIs, these objects are usually transmitted in the form of JSON structures. We will now cover how regular Java objects can be transmitted in the form of JSON, and we'll do this by making significant changes to our already existing web application. If you have taken up the courses related to SOAP web services previously in this learning path, well, we'll simply extend the example from there of a simple bookstore. So let's move along. I'll just close down the Hello World service and we'll now head over to the pom.xml. For now, let's not make any changes to this file. However, let's go ahead and add in a new class definition for the objects which we will transmit. For that, I'm going to pull up the project pane, and then from here, we'll head over to the Java directory and then create a new package. I'll call this one com.applicationEntities. Specifically, it is a book entity which will be defined in here. So I'll just right click on this package and create a new Java class. This will be called book.java. And once the class stub is up, well, let me just expand this view and then paste in the new code. Well, if you have done the SOAP web services course, the code is not really new. So this class defines what a book in our fictitious bookstore looks like. And just like in the SOAP web services course, we will integrate this application with a database where the book information will be stored. And we will then configure our web application so that it can process requests to not only retrieve the book data from the database, but also apply changes to it. However, let's move along and take a quick look at what the book class is. First of all, we import java.io.serializable, since this is a class which will implement the serializable interface. We need this in order for book objects to be transmitted by our HTTP requests and responses, and as is the case with many serializable classes, we can set a serial version UID. Following that, we set the different fields which represent a book. So in this case, we have three different strings representing the ID for a book, a title, an author, and then the price of the book, which is represented as a float. Now you may notice that I have used the underscore notation in order to set these field names rather than camel case, which is more typical of a Java program. However, there is a specific reason for this. We will soon see that when we define book objects by means of JSON structures, the corresponding fields in the JSON objects need not match the fields within the book object, but in fact should correspond to the names of the corresponding setter functions, which we will soon get to. Next, we define a no argument constructor for a book. So in this case, we simply invoke super to make use of the default constructor. And then we define a constructor which takes in 4 arguments corresponding to the book ID, title, author, and price. And we assign the passed in arguments over to the corresponding fields. Then let's head over to the different getters and setters. You'll observe that the getter and setter methods follow the camel case convention, which is common for Java. So we have getID and setID for the ID field, getBookTitle and setBookTitle, and we also have getAuthorName and setAuthorName, which is a little different from the field name of book_author. Finally, we have a getter and setter for the book price. So with that, the definition of our book is complete. However, we're not quite done with the Java code. Let's head over to the Java source and create one more package. This is called com.applicationDAO, and this is where we will define a data access object class in order to interact with our book entities. Let's call this one bookDAO, and this will be similar to what we already implemented earlier in the SOAP web services courses. So once we have the stub of the class in place, let me just go ahead and paste in the first version of the code for book DAO. So we define a method called getAllBooks, which returns a list of book objects, and this list is constructed by first initializing an empty array list, and we then load that array list with 4 different books. In this first version, we simply hardcode the data for these 4 books, and later on, we will store all of this in a database, and getAllBooks will query the database for the same information. So just to quickly summarize, I have used some made up book IDs in here, and we have the titles, authors, and prices for these 4 books. So we invoke result.add in order to add books over to the array list, and it is this array list of 4 books which this method will return. Alright then, it's now time for us to configure a web service which will invoke this method so that this can effectively be called by a client app. For that to happen, let's head over to the project pane. From there, let's head over to the com.jaxrs web service package and create a new Java class. And this will be our web service class. So we can call this one book service. And I'll just go ahead and paste in the code here. And this is what it looks like. Starting from the imports very quickly, we will need to make use of the book DAO to invoke getAllBooks. And since it returns a list of books, we will need to import the book class and further down also java.util.list. The invocation of getAllBooks will follow a get request, so we invoke the get annotation as well as path and produces. Media type we are already familiar with, and we will soon see that it is a different media type which we use in this case. And then we will also build out a response object. So let's move ahead to the book service class. We annotate this with the path annotation, and then we map this to the URL /bookservice. And then, well, we define a single method within this class called getAllBooks, and we attach 3 different annotations here. This is one which will respond to a GET request, and that GET request will be submitted to the path /bookservice/getBooks. And the type of the response is application/JSON, which maps to mediatype.application_JSON, which we include with the produces annotation. So when a client submits a GET request to the URL /bookservice/getBooks, a JSON object will be returned. However, what exactly does that JSON structure contain? Well, the short answer is a list of books objects, or in JSON speak, an array of books. So how exactly do we construct this JSON response? Well, first of all, we invoke bookdao.getAllBooks, and this will of course return a list of books. We then include that list of books in the return response, which we construct by first setting the status code to 200, which can also be set by setting the status to response.status.ok. And then we set the return entity to list of books. And this is where things get a little interesting. Will Jersey automatically convert a list of books to a JSON structure? Or is there something special which we'll need to do? In fact, there is not much work for us to do, which we will soon see. However, there is a new dependency which we will need to add over to the POM file in order for the translation of a Java object into a JSON structure. So let's head over to the POM, and in the dependency section, let's add in a new entry. This is to Jersey Media JSON Jackson. This package will automatically take care of the conversion of JSON structures to Java objects and vice versa. Once again, I'm going to make use of version 3.0.1 of this library, but if you are on an older version of Tomcat, consider using version 2.33 or older. And since I don't have this library in my local Maven repo. It appears in red text, so I'll just hit the Maven reload button, and soon enough, Jersey Media JSON Jackson has been copied over to my own file system. So we now have things in place in order to transmit Java objects in the form of JSON structures when responding to an HTTP GET request. We will test out our app in the next video. We have now coded up a REST API which is capable of returning a list of Java objects. Specifically, in our example, a list of book objects. And the question is whether it is possible for these objects to be transmitted between the server and client as a JSON structure. Let's test things out then. For that, I'm going to pull up the terminal, and from the root directory of the project workspace, we'll just run the command maven clean package. This will of course construct the war file, which we'll proceed to copy over to the Tomcat web app folder. Once Tomcat has picked up the change, well, let's first pull up a web browser and then navigate over to this URL, restapp/bookservice/getbooks. So this will invoke the getAllBooks method, which we have defined in our app, and it should retrieve 4 different book objects and then send them over to the browser. So let's see how exactly this transmission occurs and what exactly our books look like as JSON structures, and this is what we get. From the details of the books, it's clear enough that this is in fact the same information which we had hard-coded into our code. So the first book which we have here is The Adventures of Tom Sawyer, authored by Mark Twain. And then the last of these is Little Women, written by Louisa May Alcott, which is priced at $8.75. Given that we are in a browser, the rendering of a JSON structure is not quite as clear as it could be. And for that, well, I'm now going to switch over to the command line, and let's first invoke curl and then point this to the URL which invoked the getAllBooks method on our server. And once again, we see JSON data returned. Now, we could stick with the current setup and view the JSON array in this form. However, if it does seem a little cluttered, well, we can go ahead and install another tool which can be executed from the command line and is extremely useful when it comes to viewing and also accessing specific fields within JSON structures. This is a tool called JQ, and if you're on any Linux-based system, it is possible to install this using the Python package manager pip. Alternatively, you can just navigate over to the JQ download page, which is accessible at this URL, or you could in fact use any other JSON tool which you're familiar with. In any case, I'm just going to proceed with the installation of JQ with pip, and in a few moments, this should be complete. Alright then, it's now time for us to make use of JQ. So once again, we run curl against the same URL in order to retrieve all of the book objects, but this time we pipe the response over to JQ. JQ will be able to format the JSON information, and this is the output which we get. So let's take a look at the data a little more closely. First of all, what we have here is in fact an array of JSON objects, which is evident from the fact that this opens up with a square bracket and also closes with one. And then each JSON object is of course encapsulated inside curly braces. And then we have the 4 different fields corresponding to each book object: the ID, title, author, and price. However, I'd like to draw your attention to the names of the fields in each case. So the title of the book is conveyed in the field book title in camel case, and the name of the author is represented by the author name field, also in camel case. Now, this is different from the book underscore title and book underscore author field names which you have for each book object, which begs the question, where exactly do these field names come from? Well, the answer is that each of these are derived from the setter and getter functions within our book class. For example, for the name of the author, we have set author name and get author name, and that is what Jersey has referenced when deciding the names of the fields in the JSON structure. So it is author name here. Now there are ways to override this default behavior when it comes to the field names. However, that is not something we'll be covering in this course. Beyond that, we can also confirm that the details for each of the books is accurate, exactly as we had hard-coded on the server side. Well, speaking of hard coding, we all know that it's not quite good practice. So in the next video, let's replace the hard-coded book data within our server-side code and instead store that information in a database which we will integrate our application with. This course served as an introduction to the use of the Jersey framework to build REST APIs in Java. You covered how simple text data can be communicated using REST and also the transmission of Java objects in the JSON format. You kick things off by implementing a simple method which returns string data in response to an HTTP GET request. While doing so, you got to cover the use of Jersey annotations in order to construct a URL to a particular web method